Hey, good evening, everyone. Tonight on this free teach episode, we're looking at reducing balance loans with recurrent relations. So, key is we've got a reducing balance loan, which means we're actually paying down the loan while it's, like all loans, while it's accruing interest. Okay, so our example here is that Alyssa borrows $1,000 at an interest rate of 15% per annum, compounding monthly. Okay, key points. She'll repay the loan by making 4 monthly payments of $257.85. Okay, and all this first part of the question wants us to do is construct a recurrence relation to model this loan in the form, and you're given the form, so we should be all getting familiar with this at the moment. Okay, VN is the balance of the loan after N payments. Okay, so let's make a start on this one. So V0, how much did Alyssa borrow first? So that is $1,000. And Vn plus 1 is equal to R, so we need to find the R, the rate of change. So the R is 15%, but that's divided by 12 because it's compounding monthly, all divided by 100, and we would add a 1 to that. Okay, so if we jump over here, 15 divided by 12. I find these sorts of equations easier to do on a scientific calculator rather than a CAS. If some of you are out there doing year 12 with the CAS, just because of the speed and ease to get to the button. So 1.25 is the first part. Divide that by 100, and we get 0.0125 plus the 1 on there. Okay, so the bank's, this is accruing interest, so it's getting bigger. 125. Okay, so that's your R value. So Vn plus 1 is equal to 1.0125 times Vn minus, so the minus D, is how much they're taking off at each time, each payment. So each month, Alyssa's going to pay off $257.85. Okay, and that's our recurrence relation. So we can move over now. Now, some of you might have spied on the other side of the screen that there is a an answer there for us anyway. But the extension to this is over here. We've got our recurrence relation stated up the top. That's what we just came up with. So use a calculator to determine recursively the balance of the loan after Alyssa has made each of the 4 repayments. All right, so with this, we can first off clear it. Now it wants us to do it recursively, and the easiest way to do this is we first have to enter the amount that Alyssa's taken out on the loan, so $1,000. Hit your answer or equals. Now we can add in the rest of our equation, and because of BIDMAS, that will apply the multiplication to Vn, which for the first one is V0. Then subtract the 257.85 after that. So we've got an answer there. Now the first application, we would say we want to multiply by 1.0125 and subtract 257 $2,000.85. Okay, so it's stated that we want the 4 repayments. So recursively, the balance of the loan after Alyssa has made each of the 4 repayments. So we're going to go over here, equals once, twice, 3 times, and 4 times. Okay. So it wants us to find the balance at that time. So the balance after the 4 repayments, so for question 1, the balance is 0.0, let's just round to the nearest 2 decimal places, 0.4. So she still owes after that 4 cents. Okay, next up we have what balance of the loan. What balance of the loan, so the amount she still owes, that's what they talk about when they talk about balance. What is the balance of the loan after she's made 2 payments? Give your answer to the nearest cent. Now, we've already effectively done this, all the work already. All right, so on a CAS, big screen, you'll see all of your payments come up, or the balances as we go down. Over here on the scientific calculator, most of them will have a scroll function. And if we start there at our $1,000 mark, we applied it once. That brought it down to $754.65 as the balance. On the second time, we applied the recurrence relation. We got 506.233125. Okay, so if I come over here, so my answer to that is 506.233125. Now, nearest cent, we talk about second decimal place. So this 3 is rounding us down. Rounding down means it stays the same. So the balance after 2 payments is 506.23 cents. Okay, part 3. Part 3 is interestingly worded. So let's have a look here. Is the loan fully repaid after 4 repayments have been made? Okay. If not, bit of a clue. How much will the last repayment, so the last repayment, have to be to ensure that the loan is fully repaid after 4 repayments? Okay, so the key here is that if the loan isn't fully repaid after the 4 repayments, we need to know how much extra we should pay. Okay, so number 1, was the loan fully repaid? Well, our answer is right there. No, it wasn't fully repaid. Okay, not fully repaid. Okay, how much is the last repayment going to be? It has to be the normal repayment. So this is for the 4th repayment, remember. We're not making an extra repayment, but that 4th repayment, instead of being $257.85, stop here. Instead of it being that, we need to add our 4 cents to it to cut that next bit down, okay? Because of the way that money's rounded, this is a rounded figure to pay off the loan in 4 repayments, all right? But being rounded, it means that that last repayment is just out. So it'll either be usually too big or too small. So our last repayment has to be $257.85 plus 4 cents. Okay, so the last repayment is $257.89. Okay. And that's our answer. Okay. Hopefully that helps with the introductions to reducing balanced loans with recurrence relations. And we'll see you next time on Free Teach. Give it a thumbs up, subscribe, tell your friends, create accounts for your chickens, etc. See you again.